talk about solving radical equations. This will be chapter 11.3. We talked about a little bit about solving problems like this in the last chapter. So let's go ahead and take a look at this. Let's take a look at what it means, what x squared actually means. And again, the exponent 2, okay, this exponent 2, what this means is we're taking this number and we're multiplying it by itself that many times. So really what you're saying is you're saying x times x is equal to 25, okay? And what we want to know is what number can I plug into this, right? That will equal 25. Well, and this is where we get that idea of what's called the square root, right? We take the square root of this, and we take the square root of this, and this tells us that x, right, whatever number that x is, it's going to have to be 5, okay? And we also learned earlier that what this really could mean is, since we're taking the square root here, is we're finding that it could be positive 5 or it could be negative 5, okay? So that's what this means, okay? And then we also did another one where we said something like x squared is equal to 7, right? So we could take the square root of both sides here. And what we could do here is we could say that x is equal to plus or minus the square root of 7, okay? And really what we're saying is if I took the square root of 7 and I multiplied it again by the square root of 7, I could get 7. Okay? And that's really what that's saying. All right? Well, like we do in math, if I can square something, right, or if I can take the square root of something here, then what I can do is I can go the opposite way. I can square something in order to get an answer, all right? And so what I'm looking for here is I'm saying, okay, what number can I put in underneath this radical, right? What number underneath? The square root of what number is equal to 7, right? Before I had to take the square root of 7, but here we're saying what number underneath the radical is equal to 7? Well, what we can do is, hopefully you can see that that's going to be 49, right? And I'm hoping that you'll see that it cannot be positive or negative 49. It can't be negative 49, actually. It can only be positive 49. So let's go ahead, and what we're going to do is I'm going to rewrite this. X equals 7. And what I'm going to do is we're just going to follow the same rules. We're going to square this side. And if I do that, I'm going to square this side, okay? And what I'm going to get is the square root of x times the square root of x is going to be x, okay? And really, let's see, if we take a look at this, it's like the square root of x times the square root of x, okay? It's going to be equal to, and 7 squared is 49, okay? And if you remember from the last section, what we could do here is the rule of radicals, when multiplying radicals, is that if I'm multiplying two radicals, I can put them both underneath the radical, right? So this will be, okay, the square root of x times x. And I can rewrite that as the square root of x squared is 49. And so then what I can say is, well, what is the square root of x squared? The square root of x squared is x, okay? So this would be my answer, okay? And this is the really long and drawn-out way, but I want to show you at least one time why 49, or why you can take these steps, okay, the logical steps that prove that x has to be 49. Well, you should be able to see, right? If you're saying the square root of what number is 7, well, you can go the opposite way, right? Square 7 to figure out that. Okay, well, let's take a look at another problem here. So this time we have 2 radical x minus 8 is equal to 0, okay? Now, again, from earlier in the year, whenever you run into an equation, right, if you're never really sure what to do to solve it, you can always test, right? If you picked a number for x, let's say you just randomly were trying to pick one. So let's say you picked 1. X is 1. If you plug it into this equation, what would be the steps that you would follow to evaluate this, right? What order of operation would you follow? Well, first you would take the square root of this, then you'd multiply it by 2, and then you would subtract by 8, and it would get you to 0. So you can go backwards, okay? So the first thing I'm going to do is I'm going to add 8 to both sides. It's the last thing I would do to evaluate this, right? So it's the first step I do to undo it. So I'm going to add 8 to this side and add 8 to this side. And sometimes another way you'll hear people talk about this is you're trying to isolate the radical, right? You're trying to get this part, this by itself, okay? Well, the next thing I'm going to do is now I have 2 times the radical of x is equal to 8. So let's divide by 2. Divide this by 2. So I know that the square root of x is equal to 4. Now here's a common mistake people will make. They'll be like, oh, they'll say, oh, here we go. x is equal to 2. Okay? But think about this. If I take the square root of 2, does that equal 4? No. So don't skip a step here. Okay? Make sure that when you do this, we're going to square both sides. Okay? So I'm going to square this side, and I'm going to square this side. So then I get x is equal to, and 4 squared is 16. Okay? And then let's plug it in. Let's put 16 in here. The square root of 16 is 4. 4 times 2 is 8. 8 minus 8 is 0. And if you notice, see, when we checked our answer, first we took the square root, then we multiplied by 2, then we subtracted by 8. Okay? And when we didn't know x, what we did is we did the opposite. We added 8, then we divided by 2, and then we squared x. Okay? So hopefully that makes a little more sense. Let's go ahead. Why don't you take a look at this one and see if you can solve this on your own. Go ahead. Alright, hopefully you had a chance to do this. And again, if you wanted to look at your order of operations, okay, the first thing I would do, and I'll just put it over here real quick. First I would add 5, then I would square root, then I would add 7. Okay, so then what I'm going to do here is I'm going to reverse this. So the first thing I'm going to do is, okay, I'm going to subtract 7 from both sides, alright, or add a negative 7, you could say. So that's going to give me 5. Okay, then I'm going to square this side, and I'm going to square this side. And once you square this, okay, everything under the radical you get squared, so it's just going to be x minus 5 is equal to 25. Now let's take, we're going to, right, we're going to, oops, sorry, that should have been minus 5. Okay, now we'll add 5. I got confused myself there. Add 5, and we'll get 30. So x is equal to 30. Well, let's test it. Okay, 30 minus 5 is 25. The square root of 25 is 5, and 5 plus 7 is 12. Okay, perfect. Okay, looks like it works to me. Let's try another one. Okay, now we have 2 radicals and x's on both sides. So when you do these, it gets a little bit confusing because you can't necessarily plug in and reverse your order of operations because you have x's on both sides. Alright, so let's go ahead and hopefully you notice you can say, oh, you know what I'm going to do here is, since I have radicals on both sides, let's just go ahead and we'll square both sides and see what happens. Okay, so I'm going to get x plus 4 is equal to 2x minus 1. Alright, let's see. Let's move the x's. Let's take the this x and put it over here. So then I'm going to get just 1x, right? Because I'm going to subtract, take 1x away from both sides. And then I want this one over here, right? Combine like terms. I want to put my constant terms on the same side, and then on the other side I want my variables. Okay, so then I'm going to add 1, so I get 5. So x is going to be equal to 5. Well, let's plug it in. 5 plus 4 is 9. Square root of 9 is 3. 2 times 5 is 10. 10 minus 1 is 9. Square root of, there you go. It works. All right. Try another one. Why don't you go ahead and try this one yourself? Go. Okay, hopefully you looked at this and you said, well, I need to be able to combine these x's somehow. So we're going to have to square both sides. Okay, and so what I'm going to get here is I'm going to get 3x plus 4 is equal to x squared. Okay, now I'm going to bring these two things over on this side because I like when x squared is positive, right? So I'm going to make this 0, so I get x squared minus 3x minus 4. Now I have a couple options, okay? Now you can solve this multiple different ways. You can complete the square. You could use the quadratic equation. We could factor it. And so let's see, can we factor this? Do we have 2 factors of 4? Then when we add them together, I'm going to get 3. Or because this is negative, you're basically saying, are there 2 factors of 4 that are 3 away from each other? And hopefully you see that this is going to be x minus 4 and x plus 1. Okay, and if you didn't see that right away, you could just go ahead and use the quadratic equation. Nothing wrong with that. I typically don't use the quadratic equation unless I try factoring it for at least 15-20 seconds. If I can't do it by then I'm not going to waste any more time. But this one, I'm hoping you can kind of see. All right, so then when you solve this, you get, we know that x minus 4 is equal to 0, or we know that x plus 1 is equal to 0. And so then I'm going to get x is equal to 4, or I'm going to get x is equal to negative 1. So there are my possible solutions. And let's go ahead and test it. Let's see. 3 times 4 is 12. 12 plus 4 is 16. Square root of 16 is 4. So that works, okay? And then what happens if I plug in negative 1? Okay, I get 3 times negative 1 is negative 3 plus 4. Plus 4 is 1. The square root of 1 is not negative 1. Let's see. The square root of 1 is negative 1. Well, that one is not necessarily going to work, because what we're asking for is we're asking for the positive square root here. So this negative 1 here, this is what's known as an extraneous solution, okay? Because when we squared it, we sort of created two possibilities. But when you go back and check it, you realize that the square root now is going to be negative. Now, if this was a negative here, the negative one would work, but the 4 wouldn't, okay? So when we do this, that one is known as an extraneous, I think I spelled that, extraneous solution, okay? So you just ignore it. So x is equal to 4. All right, moving on. Let's try another one here. Let's try another one here. Wait, nope. Oh, nope, that is it. So, there you go. There you have it. That's pretty much the entire section. Go ahead, try these problems out. 3 to 17 odd, 23 to 29 odd, 37 to 39, and you can get some extra bonus points if you do number 32. Okay, go ahead, take your time, and we will go over these in class tomorrow. All right, good luck.